Hi, in this video we're going to look at both the sine and cosine rule together. We're mainly going to focus on when you use which rule. So an example should be given in the question, say find this angle, find this length, but it won't say anywhere whether to use the sine rule or the cosine rule. We'll also look briefly at compound questions. We have to use both of them in the same question in order to actually get to the final answer. So first, this is the cosine rule. Again, the top form is to find missing lengths, the bottom form is to find the missing angle. And the two forms you see for the cosine rule is, first is when you have two lengths and the angle in between them. So in this case, you'd be finding a missing length here. The other time you could use the cosine rule is if you have all three lengths. In this case, you use the bottom form to find a missing angle. So those are two forms you'd look out for that sort of scream to you, use the cosine rule. So either two lengths and an angle in between them, or all three lengths. For the sine rule, it's a bit simpler. So for the sine rule, if you see somewhere on the question, you have a length and an opposite angle, where you know what both of them are, in other words, neither of them is represented by an x, then that is screaming out the sine rule. So here, typically, you'd also have some other angles, like this angle is 20 degrees, and work out this length x. The key thing is, because you have this setup, that means it will always be the sine rule. Okay? Let's see that in action in a couple of questions. Lastly, we've also got area of a triangle. That's a half ABC. That is when you have two lengths and the angle in between them. So for this question, we want the length AB, and we're going to see what we have. Here, I have two lengths and the angle in between them. That means it's either the area of a triangle or the cosine rule. However, because I'm finding the length, this is going to be the cosine rule. So you would then write that down. In this case, a squared is b squared plus c squared minus 2bc cos a. And then get your labelling your triangle. Remembering the angles are always uppercase, and the lowercase a must be opposite the angle, and then b and c don't matter. From there, plug it all in, and at the end, don't forget you have to square root all the stuff because you worked out a squared there. I won't go through that because hopefully you know what to do from there. Next question, looking at this one. So here you can see, if I just highlight these two, we have a length and an angle, and we know what both of them are. Again, that is the massive clue that this is the sine rule. Let's look at some more. We notice we're trying to find a missing length. So therefore, we want the form of the sine rule we use to find missing lengths. So a over sine A is b over sine B. From there, we can then start labelling our triangle. So AA and BB. And then plug it all in. Okay. Again, I'm not going to go through this because hopefully you know what to do from this point. Okay. So next we have the lengths of the triangles are this and this and as follows. We need to find the size of the largest angle of the triangle. So whenever you have three lengths, you have all three lengths, that means it's going to be the cosine rule. Quick aside. Here we are asked to find the largest angle. The largest angle will always be opposite the longest length. So here my longest length is this 7.6, which means this will be the largest angle. Again, normally you can eye it in, but not always. Okay, let's go through that. So here we would use the angle form. So cos A is b squared plus c squared minus a squared all over 2bc. And again, you are expected to remember those. You will not be given those anywhere in the exam. We then label our triangle, so AABB, and then plug it all in. So cos of x will be b squared plus c squared minus a squared all over 2 times b times c. That gives us cos of x. So to work out x, we do cos to the minus 1 of that. So let's plug that into a calculator and work it out. Okay, so typing that all in, that gives us that this angle is 105 degrees. Once one decimal place, so 105.7. Okay, next it says, calculate the area of the triangle, give your answer to three significant figures. So this is kind of a compound question. So let's label that it was 105.7. We now want the area of the triangle. So the area of the triangle formula is a half AB sine C. And here we want two lengths and the angle in between them. And we can see we have that. We have two lengths and the angle in between them. So for this question, we're not going to use the 7.6. And again, it's worth mentioning, for this question, you have to relabel your triangle. If you go from one rule to another, you're going to have to relabel it. So I've either labeled in pencil so you can erase it, or just keep that in mind. So here we had a half AB sine C. Then I can just plug that into my formula. So a half times A times B times sine C. Then we just type that big mess into my calculator, and that will give us the right answer for us. Okay, and that area to three significant figures is going to be 10.7. So it's worth mentioning, the way these exams go in nowadays, typically they won't ask you part A. They'll only ask you part B to say work out the area. The only way you can do that is by working out one of the angles, but they won't have that as a separate part. They'll say just work out the area. Instead of splitting these marks 3 and 3, this whole thing will be worth 6 marks by itself. That's the way the questions are going nowadays. So keep in mind that. Okay, one more example going for the same idea. So here I want the size of the angle BAC. Again, we look and see what we've got, and hopefully you can notice we have an opposite length and angle. Therefore, that's going to be the sine rule. This is a nice easy one because 20 is opposite this angle as well. So it's actually not a compound question, this is a straightforward one. Let's do the same thing but twisted a bit. So here we have this setup, and we want the area of the triangle. So the area of the triangle is a half AB sine C, and for that we need two lengths and the angle in between them. And that we just don't have right now. So we're going to see what else we can use. Can we use the sine rule, or can we use the cosine rule? Here, just as before, we can use the sine rule because we have an opposite length and angle. So let's write that down. So A over sine A equals B over sine B. The only thing I can work out is going to be the length that's opposite this 82. So I can label my triangle, that's A and A. This has to be my B, which means the only thing I can work out right now is this length. There is nothing else we can work out. Again, let's plug that in. So 12 over sine of 40 is going to equal B, which I'm going to call X, over sine 82. Again, to solve these, we're dividing by sine 82. The opposite of dividing by sine 82 is timesing by it, and that goes on the top of the other fraction. Okay, we can then just type that into my calculator, and that will give me that length. So again, with these questions, if you're not sure where to start, the only thing you can really do is work out any length you can. So even if you work out a length and get stuck, you've made some progress to solving it, and you will get some marks for that. So most exam questions, you can't solve it in one go. You need multiple steps. So any length or angle you can find will be a good thing to do. Okay, that gives me X as 18.487. Again, because it's not my final answer, it helps put extra decimal points in just to avoid rounding errors further down the line. If I rounded this to 18.5, that little change might then result in getting the wrong answer for my final answer. Okay, 18.487 is this length here. I'm also going to erase my labels because they're almost certainly going to change. Okay, next we need to look at this and think, what can we find? Okay, so I can use a sine rule, but I don't have any other lengths or angles to use. I can't use a cosine rule yet. Hopefully you can see there's something else we can do that's even easier. In this triangle, I have 2 angles out of 3. We can always find the third angle because we know angles in a triangle add up to 180. So if I do 180, take away the 2 angles we've already got, that gives me that this angle is 58 degrees. Now hopefully we've got most angles and lengths here. We can finally find the area. That was the whole question. Again, for the area, you need 2 lengths and the angle in between them. And this we finally have over here. We have the 2 lengths and the angle in between them. So the area, again the formula you expected to remember, is a half AB sine C. And we plug in what we know. I will label that A and B don't matter, and C has to be the angle. Half times A times B times sine of C. From there, we've done all the hard work. We just need to ask our calculator, what is the answer going to be? So 1/2 times 12 times 18.487 times sine of 58. Then we're done. That gives me 90.1, if you want one decimal place. 94.1, sorry. That's an area, so it's going to be centimetres squared. Okay, and that's it. That's your typical compound question, where you've got to use a sine or cosine rule over a triangle more than once within a question. So my advice is, if we go back to the start question, first thing you should be doing is using any rule you can in order to work out any other length or angle. Once you've done that, it'll then become easier and easier to get towards your final goal. Okay, I hope that helped, and thanks for listening.